Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be solving two-step inequalities. This is part one of a two-part lesson. Let's start with the definition. A linear inequality in one variable is a mathematical statement that compares two algebraic expressions using an inequality symbol. Now, what I mean by inequality symbol is either greater than, less than, greater than equal to, less than equal to. Unlike equations, which have a single exact answer, inequalities represent an infinite range of numerical solutions. So an example of a linear inequality in one variable might be something like 4x plus 2 is greater than or equal to 7. Or something like 1/2 x minus 5 is less than 12. These are examples of the type of inequalities we'll be solving today. Now, before we get into the solving, I want to talk about how do you graph the solution set for an inequality in one variable. So let's look at example 1. We have a chart here, and they're going to give you an inequality. Then you'll say the verbal description, list 4 solutions, and then you'll graph the solution set on a number line. So in our first inequality, our verbal description would be the set of all numbers that are greater than -3. So our next in the chart, we want to list and plot 4 solutions. Now, -3 is right here on the number line. So the solutions to this inequality, x is greater than -3, are going to be any number that's greater than -3. So you could say -2, -1, 0, 1. You could keep going for infinity. Remember, in our definition above, it said that your solutions would be an infinite range of numerical solutions. Okay. Now, to plot the solution on the number line, you always begin, you're going to put a circle at your starting point, which in this case our starting point is -3. The circle is either going to be open or filled in. In this particular case, our circle is going to be open because -3 is not included in the solution set. Okay, now I'm going to draw filled in circles on numbers that are a solution. So we said -2 is a solution, so I'm filling that in, -1, 0, 1. I could actually keep going. I could even include decimals, 2.5, 3.5, 4.5, 5. All of those numbers to infinity are solutions to this inequality. Then the last thing you do is you shade the portion of the number line where the solutions are. So I'll shade in here, and then I'm going to draw an arrow to indicate that my solutions keep going to infinity. All right. Our next inequality, the verbal description would be the set of all numbers, I'm going to have to write kind of small here, that are less than or equal to 2. Now, in this particular problem, they can equal 2. So my solution starts at 2, and then any number that's less than 2. So let's highlight where the 2. Here's 2. So I want to list any number on this number line that's less than 2. So I could say list 1, 0, -1, and then on forever. Okay. Now, remember, when you plot your number line, you always start at that beginning point, and you're either going to draw an open circle or a filled-in circle. In this particular problem, my circle will be filled in, and that's because 2, in this case, was included in the solution. And then I'll plot my other ones I listed, 1, 0, -1. I could keep going. Again, I could use decimals. It really doesn't matter. Any number that's smaller than 2 or equal to 2 is a solution. Then the last thing you do is you shade the portion of the number line that includes your solutions. So this is the solution for x is less than or equal to 2. All right, our next inequality, the verbal description would be the set of all numbers that are less than 3. So here's 3 on our number line. Okay. I want to list some solutions of numbers that are less than 3. So because 3 is not included in the solution, I could say 2, 1, 0, -1, and so on. All right. Now, remember to graph your solution set. You start at the beginning point, which is 3. You're either going to put an open circle or a filled in circle. In this problem, 3 is not included in the solution set, so I have to use an open circle. Then I'm going to put filled in circles on the numbers that we said were solutions. Then I will shade the portion of the graph where the solutions lie. So there's the solution set to x is less than 3. Now, be careful on the next problem. Because notice that the variable this time is on the right. So before I plot the solution, I'm going to rewrite this where the variable is on the left side and the number is on the right side. Now, you want to make sure that your symbol opens up towards the x. So it would look like this. It's got to open up towards the x. All right. So this would be the set of all numbers that are, I'll have to write this really small, greater than or equal to -1. So this time my starting point is -1, and I want to list 4 solutions that are greater than or equal to -1. So this time -1 is included in the solution set because it says greater than or equal to. And then list some numbers that are bigger than 1, 0, 1, 2, on to infinity. So what I want you to do is pause the video. Try to graph the solution set on your own. When you're ready to check your answer, press play. All right, welcome back. Hopefully you began by putting a filled in circle at -1, since -1 is included. And then you put filled in circles on the other solutions. And then you shaded in your graph to include everything to the right of everything to the right of -1. Now, a solution to a linear inequality in one variable is any real number that when substituted for the variable produces a true mathematical statement. So let me show you how that would work. In example 2, it says determine whether x equals -6 is a solution to each inequality shown below. So let's start with the first one. -5 minus 3x is greater than 10. I want to know, is -6 a solution to that inequality? So I'm going to replace the x with parentheses, and I will plug in the number they gave me. I want to know, is -6 a solution? So then we'll evaluate that. This would be -5 minus 3 times -6 is -18. Is that greater than 10? So remember, we got to write subtraction as addition of the opposite. So -5 plus 18 would be 13. Is 13 greater than 10? Yes, that's a true statement. So yes, -6 is a solution to the first inequality. All right, let's see if it's a solution to the second inequality. -3 minus 5x is less than -14. Replace the x with parentheses and plug in the -6. Now we'll evaluate this. -3 minus 5 times -6 is -30. I'll rewrite the subtraction as addition of the opposite. Negative 3 plus 30 is 27. Now ask yourself, is 27 less than negative 14? No. So no, this is not a solution. All right. Pause the video and try the last inequality on your own. When you're ready to check your answer, press play. All right, welcome back. Let's see how you did. Our inequality was 1 minus 2x is less than 13. I'm going to plug in a negative 6. So this will be 1 minus negative 12. Rewrite that as addition of the opposite. So 13 is less than 13. So is 13 less than 13? No, it's equal to 13. So this would be no. Negative 6 is not a solution to 1 minus 2x is less than 13. All right, now that you know how to determine if something's a solution, in our next example, we're actually going to solve an inequality and graph the solution set on a given number line. So in problem A, we have 3x plus 2x plus 10 is less than 50. To solve an inequality, you solve it exactly like you solve an equation. Here we'll have to combine like terms. So 3x plus 2x would be 5x plus 10 is less than 50. Then we'll subtract the 10 to get 5x is less than 40, and then divide by 5. So x would be less than 8. So this is our solution. Now, what we want to do is list some values that would make this inequality true. So remember, 8 is not included in the solution, but numbers that are smaller than 8 would be like 7, 6, 5, 4, and so on and so forth. All right. Now, to plot your solution, you'll begin at your starting point, which is 8, and you're either going to put a filled-in circle or open circle. 6, 7, 8. This particular problem is going to get an open circle because 8 is not included. There's no equal sign. And then I will put filled in dots on my solution, 7, 6, 5, 4, and on forever. So this tells me that when I shade, I need to shade to the left. For less than, you're going to shade left. Less than, left. Okay. All right, problem B. 3 over 2x plus 11 is greater than 5. So I'll start out by subtracting 11. That will give me 3 over 2x is greater than negative 6. Now, to get rid of a fraction, we're going to multiply by the reciprocal. So I'll multiply this side by 2/3, and I'll multiply this side by 2/3. So over here, this will cancel out and leave me x is greater than. Here, 3 will cancel out and go into negative 6. Excuse me, negative 2 times. And negative 2 times 2 is negative 4. So our solution is x is greater than negative 4. So I want, again, negative 4 is not included in the solution. So numbers that are bigger than negative 4, let's put an open circle at negative 4 real quick. Hold on. Here's negative 4 right here. I want numbers that are bigger than negative 4. So that would be like negative 3, negative 2, negative 1, 0, and so on. So let's put filled in circles at negative 3, negative 2, negative 1, 0, to infinity. So this time, I hope you can see that you're going to shade your number line to the right. So for greater than, we're going to shade to the right. All right, problem C. N divided by 4 minus 7 is less than negative 5. So I'll start out by adding 7. So N divided by 4 is less than positive 2. Now, the opposite of divide by 4 is multiply by 4. So this 4 would cancel with this 4 and leave me N is less than, and 2 times 4 is 8. So numbers that would make that true, 7, 6, 5, 4, and dot, 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 dot. So I'm going to draw an open dot, 6, 7, 8, at positive 8, and then filled in dots for my solutions, and then I'll shade my number line to the left. Remember, less than, you shade to the left. Oh, let's box in our solution. All right. Problem D, 5m plus 5.5 is less than or equal to 16. Now, to make this problem a little easier to solve, I'm going to write 5.5 is 5.5. Okay, and I'll start off by subtracting 5.5 from both sides. So 16.0 minus 5.5. 10 minus 5 is 5. This would be 5. That would be 0. So 10.5. So 5m is less than or equal to 10.5. Now divide both sides by 5. So 5 will go in to 10.5. 5 goes into 10 2 times. Bring the decimal straight up. Subtract and bring down. 5 goes into 5 1 time. So m is less than or equal to 2.1. So because this is less than or equal to, 2.1 is included in the solution set, and I want numbers that are smaller than that. So let's graph 2.1. Here's 1, 2, a little bit past the 2. I'll put a filled in circle, and I want numbers that are less than that. So 2, 1, 0, dot, dot, dot. So let me fill those in. So we will be shading to the left. And that concludes today's lesson, Solving Linear Inequalities in One Variable, Part 1.